I could. I'm also not made of money to buy notebooks. So, like, just like my notebooks aren't made of infinite paper, I am not made of infinite money to buy infinite notebooks. They don't have the notebooks I like. Very much so, yeah. No, I like the kind with like the stuff on the to cover the spirals.
Oh, the plastic.
Well, no, it's not plastic. It has fabric. This notebook has fabric that covers the spirals, so that the spirals don't get all like clunky. So, okay, good way to start a video. So we're going to talk about integration by parts. And so the basic idea behind integration by parts is this is another method that you can take something that is more complex that you have to integrate and break it down into something that is possibly easier to integrate. So the idea is that if you have an integral of something that looks like, say, u dv, that can be made so that it's equal to uv, and why it's u's and v's, because the v looks a lot like the u, I know. I'm trying to pronounce the tail on my u so you can tell it from the v. So this is dv, that's a v, and this is a u. I'm trying to really pronounce the tail on my u's. So that's uv minus the integral of v du, where hopefully you can integrate v easier than you can integrate u. And I'm going to show you an example of what this would look like. So just showing you this formula, I know, makes it seem incredibly weird. Like, why would you ever use this? This doesn't seem right. I'll show you where this might come in. And this example, sorry? On a couple of them, maybe. No. No, you can't. There's one where you could almost use it, but it's just far enough away that you can't. So you could almost use it instead of u substitution, but you can't. So let me give you an example. And this, I actually think this is on your assignment today. So let's see. Let's say that you have integral of x times e to the x dx. And I think this is where that whole box thing that Mrs. Schwager was telling you about, Maria, comes in. So, because I think she was actually talking about this and not u substitution, but I could be wrong. So what you have to do is you've got two things going on at once here. You've got u and you've got v. So we're going to have to find out what du is, and we're going to have to find out what dv is. Now when we start out in the formula, we've got u and dv. So we have to pick one of these to be u and one of them to be dv. Now it's going to be easier to go one way than the other. Because e to the x is its own derivative, it's going to be easier if we say that e to the x in this case is dv. This is dv. It's going to be easier if we say that that's dv than if we say that x is dv, because then we'd have to like do the antiderivative of that. So I'm going to say that e to the x is dv. And then I'm also going to, e to the x dx is dv. And then I'm going to say that just plain x is u.
So what's v?
So what would be the antiderivative of e to the x? So e to the x is v. And then what's the derivative of x?
1.
Okay, so then du is 1, and I'm going to throw in the dx. So 1 dx.
So it's just dx?
Yeah, 1 dx. So the 1 doesn't really need to be there. Okay, cool. So I know what u and du are. I know what v and dv are. So now I'm going to go back up here to this formula I have laid out. I'm going to substitute everything in. So u times v, oh yeah, and then this is plus c at the end. Sorry, forgot about that. So I know what u and v are, so I'm going to do x times e to the x in where u and v go. So x times e to the x minus the integral. And now v is going to be replaced with whatever I found out that v was over here. So the integral of e to the x. So yeah, and then du I'm going to replace with 1 dx, which is just dx. So e to the x dx. Now I can do the integral of e to the x dx. I can do that just fine, right? So if I forget that this part's here, I can do this integral pretty easily. I can, right. So this is just going to be e to the x plus c. And then over here I've got x e to the x minus that.
That is,
Weird. No, weird, I know. You get to be weirded out by it. You get to not understand it. You get to be freaked out. It is an age-old tradition of everybody who's ever seen integration by parts to not like it very much.
I feel like, I don't, it just seems like a whole bunch of, I pulled this out of my back end and it works.
Okay, yes.
Like, that's what it's really coming.
No, I totally get
Like, follow these rules, and then this answer, it makes 0 sense how we did it, but.
Okay. I totally get why you're saying that, Maria. Okay. And I don't want to say that it's this way because, however, I feel like if I showed you where it actually came from, I'd lose you at step 3.
I'm really curious, though.
Okay.
I'll come in at a later time.
Okay.
So I don't, like.
Well, no, because like in the past when I've shown you, like, because remember last year, all those times when I showed you where things came from before I showed you the thing? You guys got really mad at me when I showed you where...
Hey, you over-exaggerate so much. Nobody was mad.
You guys picked up desks. There were torches and pitchforks.
That was a regular occurrence.
I remember, like, you guys have seen like that old Beauty and the Beast animated feature, right? Like I felt like it was the end where like you guys were the villagers coming for the beast. I felt like that's what it was. That's what was going on.
can you show us where this is from? 'Cause this is,
So
I really don't want to know.
So okay, right, and that's so I could show you the proof where it comes from. I feel like once I started showing you the proof, I feel like I would lose some of you at step 3. Sicily.
Are there like ones like this, like actual like, numbers?
Yes,
Can we do one of those?
not yet. We're gonna do those tomorrow.
Oh, okay. Oh, there are.
So all of these there, like e to the x.
The yes and ln x, and
Wait,
I
what-
know.
So the lnx ones would just be
1 over x.
1 over x.
Yeah. The derivative of natural log x is 1 over x, and the antiderivative of 1 over x is ln x.
Okay, LN?
The derivative of ln x is 1 over x. That should be in your notes from like a long time ago.
From back when this was way easier.
Yeah, right. And you still didn't like it then.
Okay, well, it's the antiderivative, x over 1, which is x.
Okay. The derivative of ln of x is 1 over x.
Okay.
The antiderivative of 1 over x is ln x. It's cyclical like that.
Okay.
Okay. So let's take a look at your assignment and let's do a few of these together.
One of them is already done.
There's no backside again. Question number 4 is what we just did.
Go, Mr.
1 through 6 is the new stuff, and then 7, 8, 9, and 10 is you substitution.
Yeah.
So 7, 8, 9, and 10 is you substitution. 1, 2, 3, 4, 5, and 6 is this stuff. Okay. Number 4 we just did on the board. 1 through 6 is integration by parts. 7, 8, 9, and 10 is U substitution. Okay.
Can you go up a little bit on the?
Yeah.
Just a question on like numbers like minus, like where the x has a power.
Yeah.
I think where it's like 20 x cubed dx.
Huh?
How would we do that?
So first you have to pick out what U is.
Alright, so like x plus 1.
Right. And then find out what du is.
4x.
Cubed. And then 4x cubed dx. And then you have to do a little bit of jiggering to make 4x cubed dx look like 20x cubed dx.
Oh, okay, that makes sense. That makes
Right?
Yeah.
Okay. So here, so again, u and du, and like why it's using u and v, I don't know why. It's just like every single textbook in America that teaches this uses u and v, and they're so close together. I don't know why.
Out of all
That's
the
where
letters you
you
could have picked.
I know. I
Like
know.
instead of A and B or something.
I'm aware. Like seriously, if you Google integration by parts right now, it's gonna be U and V, like everywhere in the world. So they don't. I promise you. Okay. So we got to pick what's gonna be U and we got to pick what's gonna be V. So right now it's gonna be easiest if we say that U is X, and it's gonna be easiest if we say that V or that dV is sine X, or sine X dx. So we're gonna say that U is X, and dV is sine X dx. Okay? So now we have to fill in the other parts of this little square thing that we got going here. So du is 1 dx. Yeah, it's everywhere. I couldn't find a single source that used different letters for integration by parts. And then we have to find the antiderivative of sine x. So negative cosine. Negative cosine x with no dx when we do antiderivative. Okay? Okay. So now we need to plug these non-gendered math concepts into our formula. Right?
So you get x negative cosine.
So x times negative cosine x. So I'm going to write that together as negative x cosine x. So that's uv minus the integral of negative cosine x dx. Now we can do the integral of cosine x dx, right?
Sine x.
Negative sine x, right?
Yeah, negative sine x.
So this is going to be minus,
It's sine.
because the antiderivative of negative cosine is negative sine. Right?
No, regular cosine is negative sine.
No, regular cosine is reduced.
Right. Antiderivative. You're looking at derivatives.
How do you know when you're gonna use which one? I guess
Because
that was gonna confuse me.
so okay. So if you're integrating, you're using the antiderivative. So the notes that we took, let's look back here. All right. So we're using the integral, so we're using the antiderivative. The function that we have here is negative cosine. So regular cosine is regular sine. So if it's negative cosine, it's going to be negative sine. So I'm using the integral, which means I'm using the antiderivative. If I wasn't using the integral, I'd be using plain old derivative. Okay? But if it's the integral and you're going backwards, like using the integral, you're doing the antiderivative, then I'd be using antiderivatives of trig functions. Kind of, sort of? All right. So this is going to be minus negative sine x and then plus c. That minus negative though, right, boom boom. So negative x cosine x Okay. Now I could simplify my world a little bit by making this just one old positive sign instead of two.
Is that the only way to simplify it?
No, I mean there's other ways I could, but I'm not going to force you to do any other way. Kind of, sorta. All right. Let's dive into this natural log world of number 2.
And the radical x.
Well, the radical x is fine. It's just x to the 1/2. Don't freak out about that. So we've got u du, we've got v dv.
So u is x to the 1/2.
Right. So we're going to say u is x to the 1/2, and we're going to say dv is ln x. dx. Thank you. Yes. Well, dx in this case, because that's what's actually in the problem, is dx. So let's do du first. So the derivative of x to the 1/2 is going to be
This
1/2 x to the negative 1/2 power, which is 1/2 square root x. Right? Or did I just lose like everybody?
Yep.
I lost everybody.
So it's n minus 1.
Right, because the derivative, you're dropping the power down.
sorry for doing that.
Right, derivatives and antiderivatives are different things. Oh my gosh. Aren't you so glad that you took this class? You did not have to take a math class senior year. Aren't
And
you?
I'm taking 2.
I know. Aren't you glad
Now
you
I should
took?
just drop out semester.
Aren't you glad that you took a math class? You did not have to take a math class your senior year, and you decided to bring your wonderful personalities into this math class with me every day.
What if nobody would you like get an extra credit?
Oh, it would be so awesome. Oh. Should I just make this class really hard? Tomorrow we're going to learn quantum dynamics.
Oh, that's
Do it.
I'll stay with you.
I dare you. Do it.
Okay. Okay.
Okay, if you're gonna make this class instead, then I'm coming right back on you with it. You think I might suck now as a student? You wait, I'll show you.
Okay. So now we have to do the antiderivative of the natural log.
It's just 1x, 1/x.
No.
Yeah.
Yes.
Yeah.
Yeah.
Don't make me question everything I think I know. Is that wrong?
Yeah, is it wrong?
I don't think so.
LNX?
Hold on.
Isn't it still
I'm just making sure. I'm just thinking.
for the du? Don't you have to have dx after it?
Oh yeah. Thank you.
Is that the issue?
I'm making sure. I'm just thinking. Just thinking.
What's the derivative of the ally?
1/x, which is why I don't think it's right. Okay. I get to make mistakes.
Because you only showed us the antiderivative for 1/x, not
Uh.
Wow.
What's the answer?
So it's x ln x minus x plus c.
Yeah.
Oh no.
Or
Okay. No. Okay. Stop. We're coming back to 2 and 3. Because that's not right. That's not right.
well, it's not right.
Skip?
Yeah. So number 4 we did though.
Oh, so.
Let's look at number 5.
6, we can't do that
Hey,
one.
hey, settle down. Actually, let's do it this way. No, let's do it this way. Let's not skip them. Too late. So we're gonna do it this way instead. Well, no, yes, you can. Sure. I mean, you can choose to skip the whole thing.
I'm already far into this problem.
Good. So, u, du, v, dv. Well, hold on. Okay, so here's what we're gonna do. We're gonna say that dv is x, dx, and u is ln x, 1 over x dx.
Would it be radical x cubed?
Yeah, sorry. So we're just going to rearrange this a tiny bit. And then that means that this is going to be... meh. So... x. So the third square root. 2/3. Yeah, that'd be fine. Okay. Yeah. That'll get it done. So then we'll do UV. So we'll do 2/3.
What is that?
That's
What
two.
is V?
Wait, which one? 2/3 square root of x to the third. Because if you take the derivative of this, it turns into square root x dx. We're solving this problem. This is a matter of pride now.
It's a matter of pride? Why did it become a matter of pride?
Because I'm recording this. And then... So this is x to the 3/2, this is x to the 1, or x to the negative 1.
So what are we?
Well, okay, so this is x to the 3/2, right? This is x to the negative 1.
Okay.
3/2 plus negative 1 adds up to be what? 1/2. So then this is something that we can actually integrate. So this turns into x to the, so if we turn this into x to the 3/2, is we add that power and then divide by 3/2. Yeah,
And then 2/3 divided
by 3/2 just goes away.
by. No.
Yeah.
Doesn't turn into 4/9.
No, because if you divide by 3/2, you're multiplying by,
2/3.
oh yeah, 4/9, you're right. Thank you, James. That probably deserves a Panther book. There.
Well, you can use goes from n plus 1 and 1/2 plus 1 is 3/2. So you divide by 3/2 and you get like 3/2 and then you gotta multiply.
Alright, so 5 and 6. You guys can skip. Or sorry, 3 and 6.
I mean, if you want me to skip 5, I'll skip 5. Skip them all.
Okay, I mean, you have that choice.
Alright.
So 3 and 6.
Doesn't mean I'm not still assigning you.
I